Hi, this is Carlos Cousins, and the following is an ACT science passage that is asking us for which statement in the provided answer choice supports the hypothesis of a physicist. So it turns out that physicist 1 here is arguing for something, and what they're doing here is they're not really trying to trick you. It's much easier than your reading passage from the reading test. All you have to do is focus near the end of the passage. You're going to have a thesis statement that clearly outlines what the hypothesis is. In this case, we're saying that the existence of the corona, which is this halo of glowing gases surrounding the star, right? The existence of the corona contradicts standard thermodynamic principles, right? Which state that the temperature should decrease with increasing distance from the star's core. So rather than you seeing a colder outer corona here, what you see is this area on the further from the surface is hotter. So we want to find something that contradicts the idea here, as it's reworded in the very last sentence, that the star's core produces the energy and is therefore hotter. Spiraling electric fields create nanoflares which heat the corona. So this looks really good. However, what we want is, in order to prove this, right, we need evidence that not only do these spiraling electric fields heat the corona a little bit, but we need to know that the energy here is not produced in the star core like standard thermodynamic principles would claim, and that all of this energy then is produced out here, and that's not quite what we have. Maybe the majority of the energy comes from the center of the sun, and then we just have a very small sort of heating on the electric fields of the corona. So that wouldn't really make sense. Churning from the sun's outer layers increases occurrence and results in heat production. This is the exact same thing as the previous one. Maybe increases some of the heat, but what we want to say is that we want to prove that it's actually significantly hotter over here. That as you go further away from the surface, as it says here, state that the temperature should decrease with increasing distance from the sun. Even if you do produce a little bit of heat, this isn't proof that the temperature isn't decreasing with increasing distance from the sun. Turbulence in the magnetic field bundles cause the corona to be over 200 times hotter than the surface. So this gives you evidence that there is a lot more heat production going on over here. That the standard thermodynamics model, which claims that the further you get from the sun, the colder it will be, is actually wrong when it comes to the corona. So this would have to be the right answer. And let's look at that last answer choice here. Electrical resistance heats thin gases that make up the corona. This is very similar to the other answer choices. A quick clue here for this sort of problem: when 3 of the answer choices are pretty much saying the exact same thing, it's very likely that all of them are wrong. There's no way that 3 answer choices can really make the same claim and only one of them be correct, unless there's something very specific about the way in which they're worded. But the main point of each of these 3 is that there's some heating occurring in the corona, which backs up that thesis, of course, but not well enough. It doesn't prove the hypothesis as well as saying that it's actually hotter farther from the sun than closer to the sun, because our thesis, if you remember, was pointing that out specifically, that standard thermodynamics states that the temperature should decrease with increasing distance from the star's core, and this is the only answer choice that proves that to be wrong. I hope that helped with this question. Happy prepping.